Okay, so from here, like I said in the previous exercise, a lot of times with Grasshopper, you're extracting information to use for this. So what I'm going to do is take these contours and generate a whole bunch of points to create a surface from. And so what I want to do is select all my contours here. What's the best? Let's see if I can select those, and then if I hold control, I can deselect something. So I just want those contours. And like before, I'm going to take those curves and reference them and Grasshopper, so set multiple curves. So there they are again. Like I said before, I could have easily used that other part of the script to just reference because it's generating the same thing, but this way you actually have them physically there. And you're going to learn with Grasshopper, there's a lot of different ways to generate things or get results. So I could just extract the points from these curves, or I could also generate a surface and extract the points from there. I'll look at both ways and show you what type of difficulties there might be in going about that. So I'll try generating a lofted surface from all these contours. So essentially it's going to try and create a surface from here to here and so forth all the way across. The thing with that is that they do have to be ordered and the correct direction, else it's going to like start to want to like loft from here to there, then go back, and it's unorganized sometimes. So we'll see if it just tolerates this arrangement. See, so we probably don't want to do that because as you can see, this kind of weird ribbon effect is it's trying to, looks like it says, let's loft that curve all the way back over here and then come down instead of actually going in this kind of sequential order, right? So as smart as Grasshopper is, it's also very dumb. We all know that we just want to create a lofted surface going this way, right? But you really have to kind of spoon feed Grasshopper with certain things to say, like, okay, now you can go from there to there and there. And that would require a little bit more scripting, which I don't really want to have to go over. There's another way that's just as easy. So I think so. We'll give it a shot. So instead of doing this way, I'm going to go to the curves and I'm going to divide these curves into a bunch of points. So you can see that all these curves, this is what I was talking about in that lecture before, where you can start to get information from other geometry. So in this case, I just want to find a lot of points on these curves. In this case, they're just looking at 10 points for each of these curves. I can increase that amount. So let's try something like 25. It almost starts to look more like a square grid. Maybe I can bump it up to 30. That looks pretty detailed. Basically, what's going to happen is you're going to be making all these points shift towards your drainage lines based off of their distance. So we're working from a grid of points. So in this case, I could always check to see if this is going to work out at some point by creating a surface from these points. So like I was saying, I want to create a surface, so I'll go to surface from points. I will drag this into here, and this is where we get into some of this data tree that could be really confusing. If it's dashed line, that means there's multiple tree branches, which makes sense because we have multiple curves that are being divided into a bunch of points, meaning that each one of these lines has a certain amount of points. So that's where you start to branch that data. For this component to work, it doesn't need that tree branch of data. It actually wants just one giant pool of points. So in order to do that, you can right click on these outputs where you need to manipulate that data tree, and you can see these options. In this case, I want to flatten that data tree. You're most likely only going to be using flattening and grafting. Grafting is just the complete opposite. If you want to separate data into its own separate tree branch, kind of like how you actually do with trees, where you can start to grafting them. But in this case, I want to flatten it. So now you have a solid line, which is what it wants. The next thing it needs to know is the points in the U direction. So this always gets kind of confusing. I can never remember which order it is. I'm going to drag this point counter into there, and I can see if it goes red, that means something's really wrong and it's not going to work. What you'll notice is that even though I have 30 in here, it's actually creating 30 segments, not 31 points. So imagine chopping that line into 30 segments. If there's 30 segments, there's really going to be one extra point because there's one at the end. So in this case, I'm going to try telling it to also include one more. So I can add little equations to some of these inputs. So I'm going to go to expression and do x plus 1. It changed. And now it turned gray, but I don't see anything. Did not like that. So that might be the incorrect one. Yep, that's doing this weird kind of blob of data. So let's try one more thing. The other way, it's either looking at it that way or it's looking at it the other way. And this has got 40. So I could just simply disconnect this. So it's either looking for this number or the number of curves. So in this case, there's 40. So let's get rid of that expression and do 40. Nope, that's not working either. So we are going to have to go that lofted approach, which isn't the most difficult, but it is just going to require a little bit extra time in scripting. So ignore everything from that video until this point. So like I said, it's going to loft some of these curves in a random direction or random order. So we have to basically tell it, start with the leftmost and move to the right. So in order to do that, I am going to have Grasshopper do that for me. So with these, I can essentially figure out where they are on the x-axis and just reorder them that way. Like I said, it's a little painstaking, but we have time and it's not the worst, and it's good to know. So I'm going to take these curves. I'm going to find a point on the curve. So you can see that right now it just kind of defaults it to the middle. I can move it anywhere I want. It doesn't really matter. And then from this point, they all have their coordinates, which is an x, y, and z. We're looking for that x coordinate. So we're going from left to right or on that x axis. So we're going to take that point. So I'm going to go to vector, and I'm going to deconstruct that point. So this is where I can look at all their specific coordinates individually. Like I said, I want to look at their x coordinates and order them according to that. So I've got the x. Now we can actually start to sort that. So this is where we get into our first thing with data. I'm going to go to my list and say sort list, which is right here. And it's looking for a numeric data or some type of key, as well as objects that are associated with that. So we're looking at really these curves, x-axis, not just the points. So I'm going to use this x to drag into there. And you can see it's kind of going in some random order, but now they're going to get sorted from the leftmost to the rightmost because it's just the lower value. Then I also want their associated curves with it. So I'm going to drag that into there. It's not really going to do anything. It's just reordering the data, not the actual geometry itself. So I can get rid of that. So like I said, it's not the most complicated. It's just these three components, but it's going to fix everything, hopefully. And now I'm going to loft these rearranged curves. So I'm going to go back to surface, use the loft, and fingers crossed, yay, now it's all nice, clean surface. Again, it's kind of a weird thing of having to really understand the data behind Grasshopper to understand how it creates geometry. But do you all understand this logic where for some reason these curves were in some random order, probably from height, because that's how I made the contour. So however you create the data is also the order in which that data is going to be. So if I made these contours from the low point to the high point, the first data is probably this bottom curve, right? And then it goes up, and that's why it was all out of order. But now I've celled it, okay, look at these curves on the x-axis and just arrange them because I know that's how the loft is going to work, which is nice. Okay, so like I said, it's not a most complicated thing, but it does help us out quite a bit. So now instead of dividing those curves into a series of points, I'm going to divide the surface into points. So again, I'm going to stay in my surface part, go to utilities and say divide surface. So I can drag that into there, and I'm going to do the same thing where I'm going to give it a nice dense grid of points. So in this case, you can make it a grid of points in both the U and the V direction, or in other words, the X and the Y direction. So you can start to see how it starts to get more dense with points. Using the slider, I can always increase it. Like I said, the more points you have, the more dense that information is going to be. Could create a more detailed result. It can also start to create some issues. So I'm going to keep it right around 45. Let's jump it up to 50. My computer's pretty powerful, so I'm not too worried about that. Okay, so here's our grid of points that we're going to start to manipulate. So the next thing we want to do is manipulate these points, this surface of points, based off of these drainage lines. So now I want to also reference these cyan drainage lines. So I'm going to go ahead and select all of them and try not to select these contours as well. Looks like that's all of them. And again, these are curves, so I'm going to reference them as a curve using that component. Say set multiple curves. So now you can see that they're being referenced because they're got that red hue to it. I can even turn that preview off so I can see it a little better. So similar to what we were doing before, I'm also going to divide these curves into points because I'm going to use the points on the drainage lines to be an indicator of distance with all these other grids. This is what I was talking about in the previous lecture, where you can start to use distance between objects as a form of analysis. So I can use the distance between all these points with the points that are on these curves. So I'm going to take those curves, go to the curve tab and divide it. So now you can see that these curves now have points too. And so that's what I'm going to measure, is between these and these. I'm going to add a couple more points. I'm going to double click, type 25 to get a slider, just so there's more. Again, because it's a slider, I can always adjust this later. Okay, so now what I want to do is, and I want to also flatten this. So my right click, flatten. I'm going to do the same thing with this because I just want to bunch them all into the same pool. So here's where we can finally get to the fun part. I'm going to go to my vector part, and I'll go to my point and say closest point. Don't use closest points. That's going to create a completely different result. Use closest point. I know we're dealing with a lot of points, so you'd think we're dealing with points, but in this case, it's just one. And it's asking for a point to search from and a cloud of points. And this gets a little confusing too. When I first saw that, I was like, cloud of points? What about this giant grid of points? It's actually the opposite. This grid of points is going to be the points you search from. And then your cloud of points are actually these points on the curve. And now what that's going to do is find which points or which point is closest to the drainage point. So when you're looking at this in top view, you might be wondering, or let's look at this point. So for example, it might be difficult to figure out, is this point closest to there, or there? Manually, by looking at all these points, that would take forever to have to figure out that logic, right? But that's exactly what this is doing. And I'll show you how it's working. It's not part of the script, but it's going to tell you exactly what it's doing or showing you how it's working. So again, you don't have to put this part in the script. So I'm just going to draw a line from here to here. And so that's how it's working. It's essentially taking all those grid of points and finding out which one it's closest to, which creates kind of a cool, gnarly looking graph. But see how you can start to see like, okay, that point is closest to that one. That one is closest to that one. That one's closer to that one. So now you got to actually see that relationship and distance without having to manually compute 2,600 points. Thank you, Grasshopper. Okay, so now that we have that figured out, this is where we're going to use some data manipulation to start to actually pull these points close to these drainage. So the closer these points are in our terrain, the more we can say are going to be affected by the drainage, right? The closer soil or terrain is to water, the more it's going to be affected, right? That's just kind of a common logic. So we're going to use that same premise to build our script around. Obviously, it can get much more complicated in advance, but for this first exercise for you guys, I don't want to make it too difficult. So what I'm going to do from this is use both this measurement, this distance. So it's not only telling us which points are closest, but it's actually giving us their distance. And that's going to be helpful too, because the closer they are, the more they're going to be moved or edited or manipulated, versus the ones that get further away, that are further away from water, aren't going to move a whole lot. So the distance is going to be helpful. And just like how I drew that line or made that line between the 2 points, we also want to know that direction. So we know the direction of how to move that point. Else it's going to look for a million different directions to move a point. But we want to move it in that same line. So let me just show you one more time. Try and zoom into one. So we essentially want, if we want to move that point to there, we want to use that distance to tell us how much it's going to be manipulated, as well as the direction to move it. So telling it to move that way instead of going there or there, like I said, a million other directions. So that's the value behind that as well. And so the first thing we're going to do is figure out that direction by creating a vector. So I'm going to go to vector, and it looks just like the other one, except it's an arrow instead of a solid line between 2 points. This is telling me, okay, give me that direction between my grid of points to my drainage points. And it's not going to produce anything, but it is giving us a vector that we're going to use to move these points. The next thing we want to do is figure out that distance. This is the kind of more tricky part, because we have to do some inverse logic to this because we want, again, the closer ones to be manipulated the most, right? But based off of data that has a small value, right? If it's close, it has a short distance. If it's far, it has a large distance. Therefore, if you were to use that same mathematical logic, the ones that are close or have a small value are going to be manipulated in a small way versus we wanting it to have a large. So we have to inverse that data. So the way to do that is to remap this data. Again, this was in that lecture notes. So I'm going to go to math, and in order to remap it, I'm going to go to domain and use the remap numbers component. So the first thing it needs is all the values of data, or all these distances. The next thing it needs to know is the start of those, the domain of those values. So it's giving you, I don't know, a value between 1 foot and 1,500 feet and all these other distances in between, because there's 2,600 points. It wants to know, okay, where's the closest one and where's the furthest? Give me that extent. So in order to do that, I'm going to stay in this domain and say construct or bounds. So this is, it even says in the icon minimum and maximum. So if I drag that into there, I can see that it's spitting out 8.5 and 1210 as the shortest and the longest distance. So I'm going to plug that into there so it knows how to remap this. And now I'm going to give it a simple remapped value that I'm going to edit later. I'm just going to say, okay, give the closest one a 1 value and the furthest one a 0 value. Because if I start to multiply these values, if it's 0, then it's not going to be affected because it's far away. If it's close, it is going to. Again, this is probably just way over your heads right now, but when you start to play with it, it hopefully makes sense. So I'm going to construct this domain. Like I said, I want the first value to be 1, this next value to be 0. And so now this is going to give me a bunch of new distances that I can then multiply to get that correct value. So I'm just going to take these new values and multiply them by, I don't know, let's start off with 500. And I'm going to do this incorrectly real quick just to show you what the value of adding another component to this. Okay, so I have the direction to move these points. I have my new distance I want to move them. So let's actually move them. So I'm going to double click here, type move. Asking for geometry to move. So that's my grid of points. It also needs a direction. So here's my direction, but I also need a distance related to that. So I'm going to go to vector, and use this amplitude component. This is asking for both a direction, so I can even start to see the same letter icons to match. Then it also needs an amplitude or a value with that direction. Now I'll plug that into there, and now you can start to see it gets really crazy and gnarly. So this is like where they initially started, and then as I start to move them, let's try and, is that, I think that's only them. Now let's get rid of this lofted surface too. Now you'll start to see how they begin to attract to that drainage line. So let's just make this a little bit smaller. You can almost see that these gaps are almost like ridge lines because they're starting to move away. So I'll start at 0 and watch how the points start to attract to that drainage line. Whoa. But this is why I did it incorrectly, because you can see, like, imagine those points are being sucked in by that drainage line, right? Like when you start off real slow, you can see how it's working, right? But it's going to keep moving those points infinity or whatever that value is, because it doesn't know, okay, once you've reached that drainage point, to stop. So that's why if I look at some of these, let's just kind of focus right there, that as they get closer, you can see that these first 2 points that are really close, watch what happens to them once they get to that drainage line. So I drag it, okay, they've met that drainage line, right? If I keep dragging it, they're going to just keep going and going and going and going. That's what we don't want it to do. So in order to fix that, and again, this is going to be just a whole new thing to try and comprehend, but it's not the most difficult, is that we want to use whatever its original distance is as the furthest it goes. So it says like, okay, once you get to this value, stop. Like don't go above that distance. So I'm going to go back to math, go to utility, and use this minimum component. So what that's saying is these are giving whole nother distance values, but I'm saying, okay, once it gets to its original distance away, to just stop there. So I have its original distance right here to go into A, and then this new value going into B, and whichever one's smaller is going to cap it at. So now you'll see what happens when I do that. We'll, again, just stay right there. And notice when I start to drag it, they just kind of almost vanish, right? They're just stopping right at that point. They aren't going off into no man's land. Yay. It's almost like it's getting sucked up. Let's get this plugged in so you don't lose this valuable video. Okay, so let's, again, I'll just show you what this looks like, because we're pretty much there. Pretty much done. Yay. Let's just hide that. I'm going to show the drainage lines. So now again, you can see what's happening. There's your original terrain that you've lofted with this very kind of uniform slope. And now with this script, which again, it's pretty simple compared to how it could be, I can just take this slider, start to drag it. Now you've got a whole new surface. So there's one last thing we have to do, is we have to actually create a surface from these points. So this is really just looking the same way, but now I'm going to go back to what I tried to do earlier and make this a surface. So I'm going to go to surface, do surface from points, right? And now for this, I'm going to use this same value. So I'm dividing it by 50 to get that series of points. I'm going to drag that into there, right click, go to expression, do x plus 1. Now you can see that there's a nice, beautiful surface that looks identical to what we started with. But now, this is again the fun part. This is really all you're going to have to do, is to determine how much you want to manipulate it from this original one to this new one. And I'm just going to start to drag this. This is crazy. It's almost going to look like it's being eroded away. So it's interesting because these drainage lines that are above that valley, so you can see that original valley is like right there, but that drainage line is above it, right? Those are actually being pulled up to create a new ridge line, which is kind of interesting. I don't know if I want that as my result. So this is what I was saying, where it doesn't really matter how you originally put that drainage line, because the result from the script is going to tell you what you need to do. And in this case, I want to take my drainage line. So I'm going to turn off. I'm going to go to my drainage layer, turn off everything else so I can just easily select it. You can even turn off those points, so I don't have to see them either, as well as these. Let's turn that off. So there's our drainage lines. Like I said, I just want to be able to take these, and in Rhino, I will move these and the surface will respond accordingly. So now when I start to get that drainage line almost, I'll do even less steep of a slope. It starts to actually, so I might want to even just drag it completely below that profile. So I make sure that there's always some type of river network that's being created. And then I can always make that a little bit more dramatic. There we go. You can hear my fan start up, meaning it's processing a lot. Let's give it one more second. So there you go. Now you can see like all those ridge lines have been cut through by the river. It's creating its own kind of new topography now, looking a lot different than what this original profile is, right? But now it's actually being controlled by the drainage lines. Don't feel that you have to rotate and move the drainage lines all the same way. I can even say, you know what, I want this one or this one to be a little bit higher and a little bit steeper. I can always adjust that as well. Let's see what happens. It doesn't even have to be one constant slope. You can even start to manipulate them a little bit more. So now it's a little bit higher. So now you start to kind of break it up a little bit more. You can even turn the control points on and say, okay, once it gets like over here, it gets steeper. But what's great about it is that whatever you do in Rhino to manipulate it, the grasshopper surface will follow suit. Now you've got something that's a little bit more abstract.